In the earlier lecture, we saw vectors. The physical quantities are divided into two, basically vectors and the scalars, where vectors have a direction. Okay, and then we discussed about the different types of vectors. Okay, so before that we saw how we represent a vector. Okay, so any vector, say something like PQ, we represent as a point P. This is a straight line. Okay, maybe arrow here, P and Q. Okay, and PQ is a vector. This gives a direction, and this length is a magnitude. Remember, PQ. This is a magnitude we, right? And then we defined about the zero vector. We discussed that zero vector or null vector, opposite vector, the negative vector. So for here, opposite vector is minus PQ. Minus PQ is opposite vector. So what is the minus PQ? That is a negative vector. So just the arrow will be reversed. Okay, the tail will be here and the head will be here. Okay, so this is your negative vector. And then we discuss about the unit vector. Okay, what is a unit vector? Unit vector is something which defines only the direction. It is not going to define about the magnitude, because magnitude will be 1. Okay, so how do you get a unit vector? Tell me, suppose if you have a vector AB or A, let me call only vector A. So the unit vector in the direction of A will be, unit vector is defined as a symbol is cap. Okay, that will be vector A divided by the magnitude of A. This is the magnitude of A, or sometimes what happens, they don't write this 2 dash, they simply write it as vector A by A. Okay, so when you put an arrow above it, then it is a vector. If there is no arrow, then it is just a magnitude of it. So the advantage of giving a this unit vector, this is what you call as unit vector. Unit vector is, it just defines a direction. Then you can have any vector. So any vector can be broken into, see what happens. So what happens from here itself we can see. So therefore A vector can be written as its magnitude into the unit vector. Correct. So any vector can be broken into magnitude and its unit vector. That's why the unit vector is going, this is going to just define only the direction. Okay. And so in this today's class, we will discuss about the vector operations. Some of the operations, what we are going to do with the vectors is something like we have to add, subtract, and now there are two different quantities. Vectors also there, scalars also there. Later on you see the two vectors can be combined to form a scalar, and two vectors can be combined to form another vector also. All those things we will see. So first that we call as a multiplication of vectors, that we will see in later class. Okay, and now we will see something simple. So what happens when you are going to multiply a vector by a scalar, vector with a scalar? So what I am going to do, first thing what you are going to see is multiplication of a vector by a scalar. Okay, vector by a scalar, correct. So what is that? So let us have a vector. Let us say any vector. What happened? Let's say A is a vector. And let her small k or whatever. This is a scalar. Okay. And the product of a vector and a scalar will be k A vector. This will be also another vector, B vector. What will be direction of the B vector?
The direction of the
A vector itself. So multiplication of a scalar with a vector, it is not going to modify the direction. But what it will modify?
Whether it's vector or scalar.
No, multiplication of the vector. Okay, will the vector A and B have, what is the difference between the vector A and B? Suppose if I, yes, correct. So if I write this as A vector, and K will be, B will be the same direction, but it will be, this is the B vector, correct? And what is B vector? This will be K times A vector. Okay, so multiplication of a scalar is just going to change the magnitude of the vector. Can you tell me any physical quantity where we have example where we multiply a scalar with a vector?
Force.
Very good, very good. Force is a vector. It is a direction. Force equal to mass into acceleration. Correct? So mass is a scalar and acceleration is a vector. Okay, so force will have the same direction as acceleration, but this magnitude of this F vector will be m into a, m times a. Okay, so this is where example where you have this multiplication of the vector by a scalar. So now second thing what you are going to see is addition of vectors. Okay, in the addition of vectors we have different types. One is so when the vectors are having the same direction, or you call it parallel. Okay, what I am going to see next one is addition of vectors. Okay, so when a multiplication of vector, what happens? Multi-vector scalar, what happens? There it will be again a vector, and the resultant vector will have the direction same as the original vector. Only its magnitude will be some k times, whatever the scalar times the vector magnitude. Okay, and second is the addition of the vectors. In the addition of the vectors, first let us consider the case of parallel. What do you mean parallel vectors? Okay, so let me say, for example, we are having one vector A and the another vector is a parallel, okay, maybe B. Okay, so when I add these two vectors, your C vector, that we call addition will be A vector plus B vector. Okay, so what it means, so addition of a vector when they are parallel, okay, when you add these two vectors, the resultant vector will be just the sum of these two vectors. Or otherwise what happened, if I define a unit vector along this direction, say something like, let us call unit vector here, there will be u cap. I am going to define the unit vector in this direction as u cap. Then what will have, this can be written as A u cap plus B u cap, correct? Then it will be A plus B u cap. Okay, the C vector, the magnitude of the C vector will be nothing but the sum of the magnitude of these two vectors, and the direction will be the direction of the, they both have the same vector. Okay, so this is what we call when both the vectors are parallel. Okay, and next the case comes is anti-parallel. Yeah, parallel, that means opposite. When it's anti-parallel, so what happens? That means what you are saying, so your vector A will be like this and your vector B may be something like this or wherever you have to draw B. Okay, so here what happened? So how do we going to do it? So we have to actually kind of you can add up all the vectors of the same direction, correct? So I have to convert this vector into same direction. So what am I going to do? I will take, instead of this vector, I will draw another vector of same magnitude of opposite vector. I will draw an opposite vector, okay, and that will be what? If this is A and this is B, then what this will be? So this length is same as, of course I didn't draw it same. Okay, let me do it like this. So let me draw opposite vector to B vector. We discussed already, right? What's the opposite vector? It will have the same magnitude. Okay, only the direction will be opposite. Correct? So what will be that vector? Minus B. Am I right? That's a negative vector we wrote. Okay. So then now they both have the same direction. Now you can add A vector and B vector, right? So then what happened? Your C vector will be A vector minus B vector. And now if you have defined this direction as u, okay, so then what it will be? Tell me. C will be equal to, so this is a u cap minus b u cap. So this will be a minus b u cap. So now you tell me, what is the direction of your C vector? Can you tell me? Will the direction of C vector will be A? Direction of A?
No, it depends on the A minus B.
Correct. See what happens if A is larger than B, so then it's positive. Then it will have the direction of the U vector. But if B is larger than A, then this is going to be negative. So the minus of the vector is opposite vector. So its direction is opposite. Okay. So this can be, C can be either plus U direction or the minus U direction. So it's possible. So it depends upon what is the maximum magnitude. It takes the direction of the maximum magnitude vector. Correct? If it is A is maximum, then A minus B is going to take the positive, so the direction of the A vector. If B is maximum, then you will have the direction of the B vector. Okay, so this is what we could do from the addition of a vectors in the parallel and anti-parallel vectors. Okay, there are many examples, how the addition of vectors they are given like, fine, yeah, this is what I was writing. So what we say is, all these things. So addition of parallel and anti-parallel vectors, they are basically can be defined as another vector. See, single vector. This is a one vector. Addition of two vectors will be another single vector with a magnitude A plus B and U vector. And similarly here also, anti-parallel. Okay, so something like that, if you wanted to put it in an as an example, what you want to do. Okay, I can tell you what is the example we can do. Tell me where there are two vectors are acting.
A boat on a stream. River.
All right, very good. That's exactly. Okay, you have a stream. Okay, and you are having a boat. The boat, if the stream is having a velocity v here, let us call it as capital V vector. And the boat is having a velocity here, let us call it as V vector. Okay, when the boat is going along this direction, okay, what the resultant velocity will be V plus V. So then so suppose if you want to see only this thing, only the boat, what you're going to, the whole thing, you can remove the entire water. It's something like this boat, if it is what you will see, the resultant vector will be if only the boat will move with the magnitude V plus V on the same direction. Okay, so the velocity of the boat can be written as a single vector, which is moving as a velocity of V plus V. And then opposite vector is upstream, correct? You have done a lot of problems in a mathematics in 10th standard, upstream, downstream, okay? That's a very good example, correct. So V. Okay, so here, this will be the one. So if the boat velocity is less, the boat cannot move ahead, right? The boat will be pushed by the river. So the boat velocity has to be higher enough so that it can exceed this velocity and move up. Okay, so that's what the magnitude. If V is larger, then the boat will move up. The direction is decided by the small v. If suppose for example this V is small, or the boat is just halted and there is no anchored, so then the V becomes 0. So then it take the velocity of the river. Okay, the direction will become, which is a max, because 0 is smaller than V, so we will take the magnitude. Or if there is lesser velocity also, it can't move ahead. So the direction will be decided by the velocity of the river. So this is very simple case. So yes, very good. So we had, for a case of parallel vectors and anti-parallel vectors, the resultant vector, what should be the final vector due to the combination of two vectors. You got it now? These are all doing the combination of two vectors. There can be a final resultant vector. We can easily find by adding and subtracting. Now the question is, What if they are not parallel or anti-parallel? They have a certain angle between them. An example, there are many examples you can have. In fact, yesterday itself we discussed some. As an example, I gave you the catapult. Correct? What you do in a catapult? So we have a string, correct? There's a Y based something like this, and then you have a string here, right? You pull the string like this here and put a stone, right? So what happens? So when you leave it, so this string is going to pull it here, and this string is going to pull it here. Okay, and the stone will not go either here or here. It will take a path intermediate, right? So this is the resultant vector. There are two vectors because if you take this point of the string, both the string will move towards this point. But because the stone is going to get two directions of the vectors. Okay, so but the stone will not travel along the one string. It's going to travel the resultant path. Okay, so this is what you call as addition. We will see this problem and all. I'll come to that. But before that, there are many cases I can tell you. Some other case, if you want to say, have you ever seen most of the time the rain when it falls, the rainwater doesn't fall straight vertical. It has a slanting. Am I right? There are many reasons happen. One is, for example, you have a cloud. The rain is falling from the cloud vertically. Okay. Now, if the cloud is moving, okay, so then the raindrop, one water, which is going to fall from here, it will have one component of velocity because of the gravity. Now the cloud is already moving, so there is another component. So basically, the water will be the sum of these two vectors, and the water drop will come something like this. Okay, that's why whenever you draw a child, when you draw a rain, they don't draw straight, they all start like this. And this is not just that. Suppose if there's a wind is blowing and the water is falling. Okay, the wind blows off, right? So water is having another push along this direction. Okay, so then there is again that also can cause it won't be vertical. Okay, so these are all the simple problems where you will see in physics. So this is means the vectors, combination of different vectors comes. And here these vectors are not your parallel or anti-parallel. It can have any angle. For example, here, this is not, here at least you can say, you can put as approximation, okay, this is perpendicular. But here it is not even perpendicular. It can be any angle. Okay, so it is not always the vectors are parallel, anti-parallel. They can have any angle between them. But what we have to find is what is the resultant vector. Okay, and the resultant vector, that is the vector in which the object will move or behave accordingly. Okay, one thing I forgot to tell you, when you are adding any vectors, multiplication of vector and scalar is okay. We have found force equal to mass into acceleration. You can do any scalar. When you want to add two vectors, both the vectors should be a same physical quantity. You got it? You remember that we studied the dimensional analysis also. Okay, so if you remember what we wrote, S is equal to ut plus half at square. In physics, whenever you are adding any two quantities, any terms, they all should have same dimensions. Okay, or they should have the same physical quantity. So therefore, in addition of vector also, you can't add a force and acceleration. Okay, but you can add force with another force. You can add two forces. You can add two accelerations. You can add two velocities. Like that I said, the river and the boat, they both are velocities. Okay, you can add only the same physical quantities. Okay, you can't add up. This is one important thing which I didn't tell you, so you should remember. Okay. So, and now, okay, next what you are going to see is addition of vectors when they are not parallel or anti-parallel. And they're neither parallel nor anti-parallel. So, in that case, what is a typical one rule they follow? We will come to it. Okay. What is that name? What we call triangle of vector addition. I'll write it as C. I wrote already the 2 1. Triangle of vector addition. Simple. What it says is, so we are having a vector. So let us say there is a vector, we have, okay, let me draw it like this. 2 vectors I am going to add. I am having one vector acting like this and another vector acting like this. So let me call this as A vector, and this is B vector. So now I want to find out what is the resultant of this combination of these 2 vectors. This is what we are doing in the rain also, right? Some 2 angle directions I mean. So what the triangle law of vector addition tells is, you draw the vector. Suppose if this is the A vector represented by the direction and the magnitude. Remember, this length is always magnitude. Okay. So let us call A vector. I want to call it as a ABC or PQR, something. What do you want? A. Okay. This is A and this is B. So AB is a vector. Direction is given by the arrow and the magnitude is given by B. Now you are adding this vector with another vector, say let us C. Let us call it a C. Am I right? So these are 2 vectors acting like this. Okay. And the resultant of these 2 vectors, when you have these 2 vectors, you join these vectors like one of its head will touch the tail of the other head. Okay. Under that condition, when you do like these vectors, so the resultant vector is just you complete the triangle. What is that? You join A and C. Okay, and the direction will be opposite to anti, means in the sense opposite to it. What mean direction? It will be like this. Is it opposite or same?
It's same.
No, nah. See, it goes like this, it goes like this, and it has to come like this. Then only cycle completes, nah? You got it. Either you take clockwise or anti-clockwise. Correct? So this goes like this, goes and then, but it goes opposite sense, reaches there. Okay, so that's why we call it the opposite sense. Okay, so this vector, AC vector, this is the AC vector. So this AC vector, the magnitude will be just the, draw the triangle, and whatever the length you are getting from this triangle, that will be your, that will be a resultant vector. Okay, that we call resultant vector. So what is that? So if you wanted to mention it in the terms of some alphabets, okay, so let me call it like this. Let me call it as P vector, Q vector, and so this will be R vector. Okay, so what it says is, your triangle law says is your R vector will be, they given AB there, anyway forget it, symbols are same. Okay, so your R vector will be equal to P vector plus Q vector. Okay, so this is what the triangle law of vector addition. Okay, and we will see, because this is what a combination of these 2 vectors. Okay, so you can see when the angle changes, the direction also changes. Okay, so how we are going to do addition of these 2 vectors and later on we will see, when you have some examples also, there are some examples. Okay, we will see. So the triangle law, what it says is, of course you can add up 2 vectors. So if you remember, when the parallel and anti-parallel, directions will be either at least one of the vector, correct? When the triangle law, but when the vectors are not parallel, anti-parallel, the resultant vector can be written as P plus Q. Okay, and the direction is not, it will not be P or Q, it will be somewhere else. Now here you can't write like, if you remember what I wrote there. See, if you remember in the parallel and anti-parallel, I wrote it as So this cannot be combined them. Remember that, because what happens, suppose for example, this will be UP direction, unit vector, and this will be UQ. Okay, and so this will be what? P UP plus Q UQ. You can't add them both. Okay, so because these two are two different directions, that you will see it in the later on. I think they have it in your class. This is resolving a vectors. Given a vector can be resolved. I see they have. Okay, that we'll see later on. Okay, so like what we did for parallel, we are able to add because they both are of same direction. Now here you never write P plus Q into one direction. You can't do that. They both are different directions. Okay, so that's one of the important property for this. You can use for any addition of any two vectors. What you can use is a triangle law of vector addition. You can use. Okay, so and what it says for a vector P and Q, when you represent by its magnitude, okay, and the resultant vector is just join those two ends, and that direction is the resultant vector direction, and the magnitude will be the length of this third side of the triangle. If you know one side of the triangle, second side of the triangle, then you can find the third side of the triangle if you know the angle between them also. So that will give you the magnitude of the resultant vector and the direction. Okay, clear, that's what. And there's very interesting properties of this triangle law of addition. So one is the triangle law of addition is commutative. What do you mean by commutative? What it says is, so triangle the vector addition is commutative. That means what? We are having P plus Q, correct? P vector plus Q vector equal to Q vector plus P vector. How to do that? How to find out the, how to prove this? How did we arrive this figure? If you remember, we had two vectors, right? One vector we draw something like this, and we call it as P vector, and another vector something like this, correct? And we call this as a Q vector, and we added them both like that. Why do you add like this? We can draw the same figure in a different. So what we started with the P, and then on its head we stuck the Q vector, correct? That's what we started with the P, and on its head we stuck the Q vector. Instead, I can start with the Q, and on its head I can stick the P vector. Am I right? That's also I can do because I want to add only. Okay, so let us see. For example, so if you're adding that way, so let us have, I am going to add Q vector here, and then I am going to stick, or I will draw it here. That is better, because Q will have the same direction, right? This is Q. Okay, and here then first I am going to take the Q, and then I am going to take the P vector. Correct? So this P and this P has the same direction because same vector, and the magnitude is also same. So what you will end up, it is a parallelogram. Correct? So the R vector, so summation of these two vectors will be what? Q vector plus P vector will be R vector. Okay, so let me write down the triangle as A, B, C, D. What we have from ABC, what we have, R vector will be equal to, using triangle law, when I write triangle, using triangle law on ABC, from ABC, okay, AB. So what will we have? R vector will be equal to P vector plus Q vector. Other if I write ADC, it says R vector will be equal to Q vector plus P vector. They both are same, R vector. Therefore, P plus Q vector equal to Q plus P vector, and hence proved. Clear, everyone? Clear? So that's what your commutative property of the vector addition. So now let us go for one more property, and that is what we call the associative property. Okay, associative property is interesting. So you can actually, I wrote only for two vectors you can add. Now if there's a third vector, or let us say there's a third vector which is going on some different direction. PQR vector, whatever. You can add that also, correct? You can keep adding that vector using the triangle law. Okay, so how we are going to do that? So let us see, suppose if you want to, I am removing this. So vector addition is commutative. Vector addition is commutative, that you can prove from the triangle law of vector addition. Now we want a sum of three vectors. Let us put it A, B, C only. So I am having one vector here, A, and let us say another vector here, this is B, and then another vector here, let us call it as C. So let us construct. How do we construct? Let us start with A. So this vector, I drawn it as A. Okay. So A. Okay. And then I am going to place B. B vector goes something like this. Am I right? Where it goes? Something like this. This is a B vector. Okay. And then C vector. Correct? So what it will be? Your C vector goes something like this. Correct? So now you want to find out the addition of these three vectors. How are you going to do? You know the addition of two vectors. By using the triangle law, you can find the sum of two vectors. So what am I going to do? This is simple. So let me take the addition of first two vectors. What will be this vector? Correct. A vector plus B vector. That's it, because I don't consider these two. My triangle law says vector A plus vector B equal to A vector plus B vector. And then you take this is the result of it, this vector plus this vector. Then let me join it, this triangle. Oops, sorry, triangle went up. Okay. Okay, so let us extend this vector. So make our life easier. Okay, so now what happens? So now you are adding, you forget this one now. Now you will forget this one. So now we got again two vectors, right? So that vector will be what? A vector plus B vector, which we added already before, plus C vector. Okay, and now this gives you another interesting property of the vector addition, what we call as an associative property. What I wrote first was the second one. Commutative was done, now it's associative. Associative property of vector addition. What it says is A vector plus B vector plus C vector can be written as A vector plus B vector plus C vector also. Okay, so this is what we call as the associative property of the vector addition. How can we prove this? Okay, so how we are going to prove this? Let us remove it, this one. Okay. So to prove this associative property, let us consider three vectors. Okay, so let me take one vector be A, which will be like this, and then, okay, let me take a vector which goes like this. This is a vector, which is a magnitude. The length is a magnitude, and then I will take another vector B. Okay, the length is a magnitude, and then I will take another vector C. So how many vectors are there? Three vectors. So now we know how to add these three vectors. We saw, correct? How do we add the three vectors? First we have to join these two. This is A plus B, and then join these two. So this will be what? So we got this as A, this vector is A plus B vector, and this vector will be A plus B vector plus C vector. Okay, now we want to prove this vector should be equal to P plus C vector also. Okay, so what am I going to do? How can we prove? Tell me. So instead of that, so what we did, we took this vector plus this vector. Am I right? Okay, I am going to join these two. Okay, I am going to add this vector plus this vector. Tell me what this vector will be?
B vector plus C vector.
B vector plus C vector. And then I am going to add A vector and this vector. So that will be same. Correct?
Same.
Yeah, so this will be what? This case will be A vector plus B plus C vector. You got it? Anyway, you can draw. And if you want to draw in a more simple and neat way, so you can have something like your A vector is something like this. In your book, what I am trying to write, okay, they written like this. So you had a vector which goes like this. This is the A vector, and if this is the B vector, and if this is the C vector. Okay, so what you do, one thing is what? C vector. So one thing is, you take, so how to get the resultant vector? So first one is join these two, this will be A vector plus B vector, and then join these two. Okay, so this will become A vector plus B vector plus C vector. Okay, or alternately, join these two first. Add these two first. So then what? This is the direction. So we will have something like this. You remember the direction, okay? This is the direction. So this is a direction like this. So this will be opposite direction, I said. Correct? So this will be B vector plus C vector. Remember, when you are doing these vector additions, the direction is very important. Sometimes it will become opposite. You have to take the negative of it and you have to do it. I told you always try to take the same direction. Okay, so how to get the same direction? Take the negative of it. And then, it's typically there, along the direction you have to do it. Okay, so means in the cyclic direction. When you have opposite, this vector and this vector opposite direction, what you do, then you take the negative of it. Okay, so then you get a cyclic, then you can get a condition like that. You understand? So always take the sense as the same sense. That's why I told you the negative vector. It's important. Okay. So now, okay, I taken these two and then I can add this vector and this vector. Correct? See the sense. Arrow is here and arrow is here. Correct? So then what will be I can give you this vector. What will be the direction of this vector? Like this. Am I right? Either way, this way also will get the same way. So this will be what? This vector will be A vector plus B plus C vector. So therefore, they both are same vectors, am I right? So therefore, the associative property of vector addition also we have proved. Another property of this vector addition, which is what we call as a parallelogram. Parallelogram law of vector addition. Okay, so what we saw is we took the vectors in a triangular form. When two vectors can be written as two sides of a triangle, then the resultant vector will be the third side of the triangle. Correct? So and now, but if you remember, what is the figure we draw? We took the one vector like this and another vector like this. Correct? So this is a vector and this is a B vector. We had done the A plus B vector. It is not always the case. For example, we just saw the catapult. Okay, when you have the stone here and see the vector will be like this direction. Am I right? It is not like this. It is not the tail is and the head of the another one. Both the tails are attached. Okay, so then in that case, how am I going to add the vector? So that's also a condition, correct? So here what happened, in this case, the vectors are something like this. Both the tails are added. Okay, so how you can do it is, how do you do in that case? No, it's not angle bisector, of course. No, angle bisector will come only when your lengths are all equal or something. No, these don't go into angle bisector and all. So what you have to do is, you draw a parallelogram. Okay? And the resultant vector will be the diagonal. Clear? So you draw the parallelogram and same magnitude, draw another vector in this direction. Okay, actually this is simpler to prove also. So you can actually take it a same direction. Okay, and similarly take a same direction here. So then if you draw same direction, you can see clearly this will be the addition of two vectors, correct? That's this vector, the direction also, or take here also. This is the addition of two vectors. So that's what the parallelogram law is also. It's similar, you can construct similar to a addition of this normal addition of vectors also, because take the parallel direction. Okay, so this is also possible. So this is what you call the parallelogram law of vector addition. And okay, what is important in the parallelogram of vector addition is this can, when you construct as a parallelogram, you can actually get the magnitude of the vector r. Oh, sorry, well, let us call this vector as A, this is B, and let me call this one as R. So, and if you give me the angle between these two vectors, let us call it theta, then you can actually find out from the magnitude of A, B and the angle, you can find out what should be the magnitude of R. Okay, how we can find out? How to find the magnitude of this vector R? Okay, what we will do is, let me name the vertices. Let me call it as L, M, N, O. Okay, what am I going to do is, let us drop a perpendicular from here. And I'm going to call this as LMNOP, correct? Okay, and now we have to find out. So then let us use the Pythagoras theorem. Ln square. See when we take Pythagoras theorem, we normally take only the length. Okay, so that is not going to be the direction. So just length of a triangle, right? That doesn't have a triangle. Okay, that doesn't have a vector. So just we will write down. So whatever, and that's whenever we are considering as a triangle, then it doesn't we bother about the direction. Okay, so and we also don't want to bother about direction. What a question is, what is the magnitude of R? It doesn't matter what direction it is. What I want to find out when I say what's the magnitude of R, all I want to find out is the length Ln. Am I right? So now we want to find out length Ln. What are the things we are given? We are given A, length Lm is given. LO is given, the angle between these two is given. Okay, so we have to find out what is Ln. So how are you going to do? So what will be this angle? Tell me. Yeah, it's a parallelogram, correct? It's theta. Okay, so let us do. So Ln square, let us write Ln square, that's our Pythagoras theorem, right? That's our magnitude. Ln is the magnitude we want to find out. Okay, the magnitude of R will be equal to Ln. Okay, and let me write all the magnitudes first. What about the magnitude of vector A? Tell me. Lm. And the magnitude of vector B? LO. Okay, so now let us write Ln square, Pythagoras theorem. Ln square will be equal to what? LP square plus NP square. Okay, so now LP square is Lm square plus MP. It's Lm plus MP, correct? So this will be what? This will be equal to Lm plus MP. Am I right? Plus NP square. So what this will be? Tell me. Lm square plus MP square plus 2Lm into MP plus NP square. Okay, so let us see. So what is Lm square? Lm square is our mod of A. Okay, A square. And MP square, LM we got it, and MP we have to find out, right? So MP, so NP square and MP is given, right? NP square will be what? Again, this is also no, better. Well, let us write it in terms of, okay. So let us write this. This is a theta. Okay, what will be the cos theta? Tell me, in this triangle.
NC by NM
Cos theta will be equal to what? NP
by NM
by NM. And what will be sin theta?
NM.
Oh, this is NM. Huh? Correct, NM. What will be sin theta? Tell me. MP by NM. Sin theta, na? Sorry, NP, correct. And what I written? Cos theta is, I written wrong. Cos theta is MP by MN. And sin theta equal to NP by NM. So now you can understand. See. So what this will be? So MP. Let me write MP. MN is what? MN will be nothing but P. Okay, so this will be MP by B. And this will be NM. NP by B. Okay, and here, right, what is LM square? LM square is A, correct? So A square, I'm not putting the arrow, okay, means small, there's a magnitude of it, plus MP square. MP square is what?
B cos theta.
B cos theta whole square, na? So it will be B square cos square theta. Am I right? Correct. Plus 2 LM. LM is what?
AB cos theta.
2A and MP. MP is what? AB cos theta plus NP square. What is NP square?
P square
Sin square theta. P square sin square theta. Am I right?
cos theta sin square.
Cos theta, so we're going to A square plus B square. So what you are going to get? Ln square, where ln square is R square. Correct? Magnitude of R whole square will be equal to, or simply write it R square. Correct? That means this domain. R square will be A square plus, if I take B square commonly outside, cos square theta plus sin square theta becomes 1. Therefore, this becomes B square alone, right? So, B square plus 2AB cos theta, or R equal to square root of A square plus B square plus 2AB cos theta. You don't write plus minus. Why? This doesn't have a direction. Okay, it's a magnitude, na? So it doesn't have, it's only the length. Okay, when you write a magnitude, only the length. Okay, so this gives you the magnitude of the resultant vector. So if you remember in earlier triangle law, we just draw as a triangle, correct? Suppose if you ask me, so given a vector A and a given vector B, so what is the resultant vector magnitude? Will be magnitude of A vector plus the magnitude of A square vector, square root of A square vector plus B square vector plus 2 times AB into the cos of the angle between them. Okay, so it is not angle bisector as you said. Got it? Fine. So this is the way you find out the magnitude of the vector. We can do further one more thing. So what you can do, okay, now when you know the magnitude of the vector is also no, but now we wanted, okay, so then when any two vector is operating, so if I give you any two vector, you can say what will be the resultant magnitude of the vector. What does it mean? Just by taking the magnitude, all you need is the magnitude of this vector and the angle between them. That's all you know. Then you can find out what is the magnitude of the resultant vector. Now I'm asking what is the direction. You want to know the direction also. So then what happens? So typically I can say, if I call this is the alpha. So the angle between A and what is the resultant vector? The angle from the vector A. Okay, or maybe from B also. We will see that. So how to get the angle between the, direction of the resultant vector? All you need to know is what is the angle from the vector A. Okay, let us find out the alpha. What do we get the alpha? Okay, how do we get the alpha? To get the angle of the resultant vector, what we will do is, so this is the angle we want to. Okay, I shouldn't put an arrow here. Okay, so don't confuse with the arrow. It's just an angle we are doing. Huh? Already the direction is decided by the vector itself. So we don't should have the arrow there. Okay, alpha. Alpha. If I able to find out alpha in terms of my original vector A, B, and theta, that's what gives me the resultant angle alpha. I know what will be the direction of the resultant vector also. So in the earlier step, we got what is the magnitude, and if you are able to find out alpha, that's all I want to know. In what direction it will go and what is the magnitude it will go. So in a catapult, when you pull and throw, okay, when you pull it like this, when you leave it like this, or when you leave it like, right? You have a catapult like this, right? You pull it straight, you know from where the stone is going. To know the stone, you have to know what is the magnitude. Given this A and B, you know the magnitude. Now when you want to get the direction, you may not be exactly pulling this, you may have slightly tilted. So now the stone may not go exactly as an angle bisector as you are telling. Okay, it may go slightly different angle. So what you want to know, as well as the magnitude, you also want to know what is the angle that will give you the direction. Okay, this angle is alpha. So okay, so we can find out this easily. And tell me, okay, for this alpha, let me take tan alpha. Tell me what is tan alpha? NP, correct? By LP. Fine. So LP is what? LM plus MP. Correct? So NP divided by LM plus MP. Oh, sorry, MP. Okay. So what is NP? If you remember NP, na? So if you take sine theta, we wrote it earlier, right? Sine theta equal to what? NP divided by NM. Right? NM. Correct. That's what B. Am I right? This is a B. So NP by B. Therefore, this gives you NP equal to B sine theta. Okay. See that the letters and the symbols are different in your book. Okay, but the procedure is same. Don't worry about it. When you want to follow the book, you can follow that whatever the notation is given in the book. Okay, and what all you want? We want to get the MP also, correct? So NP somehow we got it. So we want to get MP. So let me write it down. So NP is what? B sine theta. LM is known, right? LM is A. A, correct. A plus we want MP. Correct, exactly. Cos theta equal to what? Cos theta of this will be MP divided by NM, and that is equal to MP divided by B, or this gives you MP will be equal to B cos theta. So this gives you B cos theta. That's all we got. Okay, we want to find out alpha, right? So see the condition here. Theta is what we given. When I pull the catapult, that much I should give what is the angle between the two strings. When I pull longer, then the angle is going to become shorter, correct? When I pull it less, the angle becomes larger. So you give me the angle, and then the two vectors. When I leave it, what is the velocity these 2 points are going to move? Okay, give me those two vectors. Then I can tell you what is the resultant vector in which the stone goes. You understand? So, and correct. So this is what. So actually usually what they write, so therefore you can also write alpha will be equal to tan inverse. You remember I told you this. When you take tan alpha is this, so the symbol is, for alpha will be tan inverse of this whole quantity. B sine theta divided by A plus B cos theta. Okay, so now there can be one more thing also. Suppose if I ask you, okay, I don't give you the angle, give me the angle between not from A, give me the angle between B, B and the resultant vector. Let us call it gamma. How will you do? Same thing, rotate it. Bring this at the bottom. Okay, bring to the bottom. Do the same thing. Okay, what will you get? Tell me.
You get the perpendicular from M to.
Correct. From here, you extend it here, put the draw here, and then do the whole thing. Just time rotate it. Rotate the parallelogram. See, now we have put this as a base, A as a base, correct? Now we put B as a base. And then next time do the whole same procedure. If you do, you will find out it will come out to be same way, same formula. What will you get is, so in that case only your, because see what happened is your A, in that case A will be replaced by B and B will be replaced by A. Okay, all just you replace it. So if you want to find it in terms of gamma, let me write it as a, I don't write gamma, I will call it as beta, alpha beta. Okay. In the case of beta, will be tan inverse 1 of B will become A sin theta divided by B plus A cos theta. Okay, so this is the way you can get the both angles also. Whichever the angle, you can find it out. Otherwise also it's very simple. See, otherwise what you want to do, it's simple, tan alpha. Na? If you want to take beta, beta is what? Beta equal to? Correct. Theta minus alpha. You know tan, you already done in the trigonometry formula for tan A minus B. Use that formula, you will get the same. Okay, you got it?